on since the start of the year. The vroom package is used to read rectangular files such as CSV, TSV, and fixed width files quickly into R. What do I mean by quickly? So for a 1.5 gigabyte file, I would say a moderately sized file with 14 million rows and 11 columns, the vroom package is able to read this file in a little under 2 seconds at nearly 1 gigabyte per second throughput. And you can see the results from other packages such as datatable and readr and the base function read.delim for the same file. So how is vroom able to do this? And I should also mention that the majority of the API in vroom is very similar to the readr package. So this tour will really be focusing on features unique to the vroom package. So first, let's just load up our packages. So the first new feature in vroom is the ability to read multiple files into the same data set. You can do this by simply passing a vector of the file pass. So here I have a vector of 4 different files from this trip fare data. This is New York City taxi cab fares. Each of the files is around 1.5 gigabyte in size, and for a total of a little over 6 gigabytes. And I can read them in vroom with one call to the vroom function, just passing that those file paths directly to it. So what's the big idea? How is vroom able to read this so much quicker than other existing packages? So when vroom is doing this initial reading, it's simply indexing the file. So it's finding all of the locations of the delimiters and the new lines, but not actually reading the values and parsing the values of the file. And that's the real reason that it's able to read this so much faster, is that we're delaying parsing of the values until we need them. And we're able to do this because vroom uses the altrep framework to store alternative representations of the vectors. And this framework is available in R 3.5 plus, and it allows packages that use it to provide alternative memory representations of their data. But the important distinction is that no existing package code needs to change in order for that to use these alternative representations. As far as other packages are concerned, they can interact with the data in exactly the same way, which means that none of your existing R code needs to change. So I can demonstrate this. We can do all the normal things you would do with data sets. You can print the data, and we can see that it's 59 million rows and 11 columns in all of these files. I guess another new feature in vroom is this overview of the file types when it does the initial reading. So you get the number of total observations, you get the number of columns, and you get the file types, including the counts of each of the files. So this data has some character columns, mostly doubles, so it's mostly numeric, and one date time column. And then, like I said, we can do all the sort of normal things you would do. You can get the dims of your data, you can get the size, overall size, you can take the head and the tail, you can look at the beginning and the end, and you can even sample rows within the data. And all of this is very quickly, even though we haven't actually read all of the values until we need them. And it's quick because we're really only operating on a small subset of the full values. We're only having to pull in those values for a small subset of the entire data. Now I'm going to switch over and we'll do some more, I'll go through some more examples, some more benchmarking results to try to show you sort of some distinctions on when vroom works well, when it maybe doesn't work as well. So this is the same data set, just one of the files. It's just the first file in that data set. And for this file, it's 14 million rows, 11 columns for 1.5 gigabytes total. So the first two things I think to focus on are the readr results and the data table results. These are the two packages that currently exist for reading. These are the best in class for reading rectangular data now. So for this data, data table is quite a bit faster than readr. It's maybe 2.5 times as fast. And I guess the other thing to mention is the colors in these bar charts are different actions. So the green is actually doing the reading. That's the most time-consuming step. But then we print the data. So it's basically what I just showed you: printing the data, taking the head, taking the tail, sampling rows, a few rows within the data. Filtering. So that I didn't show, but that's basically filtering based on one column the rest of the data, and then aggregating is doing like a grouping step, and then taking the median or mean of one of the columns, doing sort of a grouping summarize step. So readr and data table are here. If you use vroom without the alternative representation framework at all, then it sort of slots in between these two packages. Still quite a bit faster than readr, mainly because vroom uses multiple threads when it's doing the indexing, and readr does not. And a little bit slower than data table. And then the bottom part here, base and dplyr, is two ways of doing the rest of the manipulations. So basically, for each of these labels, the top part corresponds to the reading step, and then the bottom is what's used for the remainder of the steps. So if you don't use alternative representations, vroom is still quite an improvement on readr for this data. If you do use alternative representations, that's where you get the additional benefit. So these first two are using either alt-rep just for character vectors or for all of the data types. And if we use them for all of the data types, we get a significant increase in the overall reading time. If we only use them for characters, we still get quite a substantial increase in our reading speed, but not quite as good. And using the base functions is a bit slower than using dplyr for the same for the aggregation. Particularly the aggregation step is quite a bit slower using base R. The other thing to point out is this green bar. So in all of the other cases, the green step did not take really any time, which is why you don't see it in the graphs. In this, the reason that it shows up when using dplyr with full alternative representation is due to a way that the RCPP package works with numeric vectors. So basically, what happens when you're using RCPP and these numeric alternative representations is that all of the data ends up being forced to be read as soon as you use RCPP on one of these numeric vectors. This is a known problem that I'm planning on fixing in the future, but for now, basically what this means is as soon as you use a package using RCPP, such as dplyr, the numeric data is no longer lazily read. It has to be eagerly read in that case, which is why we see this overall time basically is equivalent to using normal vroom with alt-rep and full alt-rep, because as soon as you use RCPP, it's no longer all of that numeric data is read. So this plot is showing the time to analyze a data set that This is just this is no longer a real-world data set. This is now just a simulated data set that contains nothing but numeric data. So this is 1,000,000 rows, 25 columns. It's around 0.5 GB in size, and this is just numeric data. This is just doubles, in fact. So we can see so the first thing to point out is that the x-axis here is much faster now. So if we go back to our previous plot, this took around like 40 seconds for readr to read the other data. This is only taking around 5 seconds, 5.5 seconds to read the whole data set. So this is both due to the fact that this is a smaller data set, but also it's numeric data is in general much faster to read and parse than the equivalent data set in character data. So the next thing, again, I think it's important to look at sort of our benchmarks here, which is readr and data table. So data table to read numeric data is extremely fast. So if you have data sets that are only numeric data, you won't be able to read them in more quickly than using the data table package. But if we do use vroom to do this, we can still read this data quite quickly and much quicker than using readr currently. So vroom is, regardless of what method you use to do the manipulation or read in the data, if you're using altrep, if you're not using altrep, or if you're using full or normal altrep, you basically can read it extremely quickly. And it doesn't matter too much which of those you use. But the only caveat that because of this issue with RCPP interacting with the altrep vectors, if you use full altrep and then use base functions to do the manipulation, that ends up being a bit faster for this example. And that is the only one that really becomes somewhat comparable to the data table results. So the picture changes if we instead switch to looking at only all character data. So this, so now if we look at readr at the top, it's still the slowest, and then data table. So again, this is actually a smaller data set than previously, but in terms of overall size, it's only 382 megabytes. But it takes much, much longer to read. So even data table is taking almost 35 seconds to read this data. And this is only character data now. Again, this is simulated data. So if we don't use altrep with vroom, we see it slots in sort of in between the dplyr and data table results. But the real advantage becomes when we do use altrep for this data set. And this is really where I think vroom shines. So if we do use altrep, the reading time basically goes to nothing if you're using only character data. And even after doing the manipulations, we're still way faster than any of the other packages. So this result is really, I think, the strength of vroom. If you have character data, it's going to be much, much, much faster than any other way to do this. Okay, now we can go back to, let's go back to our demo and do some more, I'll show you some more features of the package. So one new feature is that goes in conjunction with the ability to read multiple files is the ID argument. And this allows you to put the path to the files in your final data set. And this is often useful in practice because often these paths actually have data within them. So maybe the date that the experiment was run is encoded in the file path. Or maybe the type of instrument is included in the file path. So you often need to get this data encoded in the paths back into your data set anyway, and the ID argument lets you do this. So I'm now using just force files that are the same files we used previously, but now only the first 1,000 rows from each of the files, rather than the full data set. So we end up with just under 4,000 rows because of the headers. And we can see that the path argument, so you give ID the name that you want the column to be with the paths in it. So I'm going to name it path, and then we can look at the head of the path, see that we're getting our full path, and then we can do table of the path to see that each of the files we get 999 rows, which is what we would expect. Another new feature is the use of the call select argument. So often when people are using vroom or readr in conjunction with dplyr, they'll read in all of their data initially and then later on select only a certain subset of columns to work with. So in this first example, I'm selecting a few different columns, the medallion, the pickup date time, and any column that ends with amount. And I can do that, and we get back 6 columns. But with vroom, you can actually do this without needing dplyr at all. So you can use the call select argument with the exact same, basically the exact same syntax. So everything within this list call is exactly equivalent to the equivalent select call, including the same semantics, such as using the selection helpers, such as ends with. And this is also a bit more efficient because we don't have to read in these additional columns initially and then discard them later. We can do the selection as we're reading in the data. You can also do things like remove a column with a minus and the column name, or rename columns. So here I'm renaming the medallion column to taxi and then taking everything else. We can just verify that the first column is now named taxi, because that's the taxi medallion. Another new feature is the support for the name repair argument. So this argument comes from an argument of the same name in Tibble and Read Excel. And this gives you very flexible ways of doing what we're calling name repair. So what is name repair? So that's basically repairing the column names of your data. So by default, vroom will just do minimal name repair, which means that it just makes sure that the columns are syntactically correct, so they can be called as R columns. But you can do other things, so you can also do things like convert all of the columns to uppercase by just passing a function to the name repair argument. So toUpper will convert all of our column names to uppercase, so we can see that they're now all uppercase. But one way you can make this even more powerful is using functions from the janitor package. So this is a great package that is used for doing these sort of initial pre-processing steps. And it has a function, make clean names, that we can use to do various things, like to do more sophisticated manipulations of the column names. So you can convert the column names to lower camel case, so we see our column names are now lower camel case rather than using snake case like is in the initial data, or even do a lowercase uppercase if you really like that style. Of course, I prefer snake case for my column name, so that's generally what I would use in this case. Another new feature in vroom is the vroom lines function. So this is analogous to the readr readlines function, but it also takes advantage of the lazy abilities of vroom to read in the data lazily. So one use case where this is really useful is counting the number of lines in a file. So often, one way people do this is using the WC program on the command line. So let's try that with our data set, our tripwire data set, and we'll see how long that ends up taking. So this took about 1.5 seconds to run, and we get our result back 14 million lines. So we can use vroom lines to do the same thing, and we'll see how long that ends up taking. So that took a little less than 1 second, and we got the same result. So rather than having to rely on command line tools to do this, we can get the same result within R using the vroom package. And we can also do additional things with this data. So this is, like I said, this is the lazy representation of the file. So you can easily look at the head of the file, the tail of the file, or even sample within the file, sample lines from within the file. So we can also, so vroom has very good support for reading from R connections, and this allows you to do a number of useful things. So the first of which, and one that you might be familiar with in the readr package, is reading from compressed files. And you can, vroom actually does this with behind the scenes anytime you give it a file path with the appropriate extension. So here I have a compressed version of the same data we've been working with, and we can read that in vroom just by passing the file name, and it will. Well, the file doesn't actually exist, so we can create the file. Let me do that in the terminal. Gzip small. Okay, so that now has zipped up the file. Now I can read this, and vroom reads it just transparently behind the scenes. And so what's actually going on here is that vroom is creating a R connection using gz file, which is a built-in function in base R to create a gzipped connection to a file. And then in the background, when vroom is indexing, it streams the uncompressed data. It indexes the data and then streams it to a temporary file, which vroom then uses to do the lazy reading as needed. And then once the vroom object is destroyed, once it's removed and destroyed, the temporary file is automatically cleaned up. And this would also happen if the R process ends. You can also read from remote files. So this is doing basically the same thing, but using a file from the internet. So it uses a curl connection from the curl package to create an R connection, and so that downloads the file, and then vroom can read it transparently. So you can see that works in just the same way. You can also use pipe connections. So a pipe connection is used to run a program from a shell and then pipe the output of the program into R. So this is really useful for doing like pre-processing using command line tools. So let's say, for instance, that I want to, so this first example is looking at disputed claims. So that's what DIS is. I'm grepping for that. So grep is a command line tool to search text files for specific text. So I'm searching for this DIS field in our small data set, and then piping the result. So the pipe function is used to create a pipe connection for a command. So I'm piping the result of this command line command to R, and then reading the results with vroom. So actually, I'm just going to run this on the command line and show you what that looks like. This doesn't. I might have invalid argument. So apparently small, I think, doesn't have anything. Okay, so I think there actually were no disputed claims in the small files, which is why that one's not returning anything. But if we take just the first million rows of each, oh, I think I know what I wanted to do here. So this should actually just be tripvar1 CSV. So I'll just look at this first CSV file and pipe that. This will take a little bit of time to run because grep is quite fast, but this file is fairly big. So this will run in a few seconds, maybe 30 seconds. And then we'll get our data set. We can see it's now coming in. So based on our 1.5 gigabyte file, we're only reading in a fraction of the total file into R. It should be done relatively soon. And then, so this is really useful when you have extremely big data that maybe won't even fit in your R's memory, and you want to extract just a subset of that. And we can also do this with multiple files. So here I'm taking just the first million lines of each of the big files and grepping for this disputed claim key acronym. So I can do that, and this should only take a fraction of the time because taking the first million rows is relatively fast, and then doing the actual grep is relatively fast. So this shouldn't take too long either. Yeah. And then we got back 693 results. So that's a way that you can take advantage of the existing tools in the powerful Unix command line in conjunction with vroom, to read in your data very quickly. So another new feature of vroom is the vroom write function. So this is a multi-threaded function that also supports R connections. And so of course we can write the file. So what's df in this case? So we can write our file just as a regular file, but we can also transparently write it as a gzip file. And this will automatically compress the file for us, again, using an R connection. So that's very useful. It's very convenient. But you can also do more sophisticated things. So again, we can use pipe connections also when we're doing output. And here we're piping our results to the pigs command line tool. And this is a multi-threaded gzip compressor. So this is actually quite a bit faster when writing than relying on just a single-threaded compressor built into base R. So you can do that using the pipe and like that. You can also do things that aren't built into base R. So a fairly new compression format is Z standard, and there's no existing connection for this in base R or any CRAN package that I'm aware of. But we can write our file transparently to a Z standard format by using the pipe connection and then piping it to the Z standard command line tool and directing that output to a file. And if we actually look at the file size of our 3 files we've just written, we can see that they've all been compressed. So our initial file was 600 kilobytes. The gzip file is 187 kilobytes, and our Z standard was even smaller than that. And then we can use vroom to read back in these compressed files. So I already showed you reading back in a gzip file, but we can also, again, use our pipe to read in the Z standard format as well. So people often ask me what the future of the readr package is now that vroom is on CRAN. So I'm the maintainer of both readr and vroom, so people are curious at sort of what the future holds for these 2 packages. So the plan, so it's still a bit unclear, but our plan is to sort of let them both evolve separately for a little bit of time, and we'll see sort of how the uptake of vroom is compared to readr. But I think down the line, eventually we will have vroom become the backend to read R, so that you can use your existing read R functions in essentially the same way, and they will just end up being much faster. So finally, the vroom package. This is an introduction to the vroom package. It's available on CRAN, so you can install it with install.packages vroom. You can read more about the package, including the benchmark results I showed here at vroom.rlib.org. And if you have the vroom is a new package, so if you use it on your data and you run into issues, shouldn't be a huge surprise. If you run into a bug, please open an issue at the GitHub issue tracker, rlib/vroom/issues. And I hope you enjoyed this sort of tour of the package, and please try it out and let me know if it works for your data. And if not, please open an issue. Thanks, and I'll see you guys next time.